Hello viewers, welcome to my channel. In today's video, we are going to see problems related to propositional calculus. If the problems are given in sentential form, then first we convert into logical expression, that is symbols with logical operators, and as usual we solve the problem. Let us see the problems. First, we are going to use conditional operator, which is defined by means of truth table. Here P, Q or any two proposition P to Q. This is a how we are denoting P to Q. This is given by truth table like this. Some other forms of conditional operator P to Q are given. That 7 forms are given. Like P implies Q, if P then Q, Q if P, P only if Q, P is sufficient for Q, Q whenever Q is necessary for P. Here consider a very simple example. P is it is below freezing, Q it is snowing. Now how to write a compound proposition in symbolic form? If it is below freezing, then it is also snowing. That is of the form P to Q. This is P to Q. Here next one, second statement, it is not snowing if it is below freezing. This is of the third form, Q if P, then I get the answer as P to negation Q. Below freezing is a necessary condition for it to be snowing. It is of the seventh form, then I get the answer as Q to P. It is below freezing only if it is snowing. Then I get the answer as P to Q. And then it is not below freezing whenever it is snowing. This is, I use the sixth form of the conditional operator. Then I get the answer as Q to negation P. Then I have an example which is given in sentential form. First, I have to convert into logical expression. That means I have to assign symbol for each statement, and then logical operators are there. Here, for example, and operator is here, and then operator is here. Then here, first I assign a symbol for each statement. A denote it is sunny this afternoon. B is the statement it is colder than yesterday. C is the statement we will go swimming. D is the statement we will take connectives. E is the statement we will be home by sunset. Then the above statement are given in the premises form. Negation A and B, C to A, and negation C to D, D to E. That leads to the conclusion E. I have to prove this one by means of direct proof. Here, first step I have taken negation A and B is true statement. Again, all the things I have taken. C to A is the second step. Third step, negation C to D. Again, fourth step, D to E is all the given premises. The first step, negation A and B, leads to negation A is true by means of the simplification rule. Here, C to A. Step number 2, C to A, we take contrapositive for step number 2. It gives negation A to negation C. Negation A is true in step number 5 and negation A to negation C in step number 6. By applying modus bonum for these two steps, I get the answer as negation C is true. Again, in step number 7, I combine and step number 3, negation C to D, I get the answer as D is true. That is in step number 8. And then D to E is true in step number 4. Again, I apply modus bonum for these two steps. I get the answer as E is true, which we want the conclusion. Prove the following premises are inconsistent. For this problem, in order to prove the set of premises are inconsistent, we get the final answer should be a contradiction, that is 0. Here all the statements are given. Here in sentential form it is given. Now we have to rewrite in symbolic form, then we have to solve it as usual. Here I have assigned Jack misses many classes through illness as E, and S denote Jack fails in high school. A denote Jack reads lot of books. H denote Jack is uneducated. Then if you apply, then the premises are E to S, S to H, A to negation H, and E and A. First I have taken the premise. E and A is the premise. This means E is true as well as A is true. This is given in step number 2 and step number 4. E to S is a given premise and S to H is a given premise. I apply chain rule, then I get the answer as E to H in step number 6. And then here if I combine step number 2 and step number 6, that is E is true, E to H is true, then H is true by modus ponens. And then given A to negation H is true is a given premise. Then step number 3, A is true, and step number 6, here step number 6 it is H. Here A is true, H. This is step number 6 is E to H is 2. Now you take contrapositive for this one, negation H to negation E. That is, you get, A to negation H is 2, it's given, and then apply step number 3 and step number 8. I get step number 8, I get step number 9, that is negation H is 2. Here H is 2 by means of step number 2 and step number 6 I get step number H is 2, that is E to H is 2, then H is 2 by modus ponens. Here H is 2 as well as negation H is 2, H and negation H is equal to 0. Show that the following set of premises is inconsistent as usual in the last problem. Here if the problem is the contract is valid, then John is liable for penalty. If John is liable for penalty, then he will be bankrupt. If the bank loans him money, he will not be bankrupt. As a matter of fact, the contract is valid and the bank loans him money. You assign a statement for each statement. If the contract is valid, you assign it as some letter A. Then John is liable for penalty, you assign it as B. And then John will go for bankrupt, you assign it as C. And then D, the bank will loan him money. All the symbols are assigned. Then the given statement is converted in symbolic form like this: A to B, B to C, D to negation C, A and D. This is a given premise, but in the problem they ask, show that the following set of premises is inconsistent. So as in the last problem, if I use all the symbols and then if I use chain rule and then modus ponens repeatedly, I get the answer as C and the negation C is true. Then fourth one, show that the hypothesis, if you send me an email, then I will get then I will finish writing a program. If you do not send me an email, then I will go to sleep early. If I go to sleep early, then I will wake up feeling refreshed. Lead to the conclusion, if I do not finish writing the program, then I will wake up feeling refreshed. This is the conclusion is of the form conditional conclusion. In this case, if the conclusion is given, now you take condition as one of the premise, that is additional premise, and finally you prove the conclusion is true. That means when I convert into symbolic form, I get P to Q, negation P to R, R to S. That leads to the conclusion negation Q to S. That means you take negation Q as an additional premise and finally you get a conclusion as S is true. That is, negation Q is an additional premise, P to Q is true. Then by contrapositive for this statement, and then I get, and using step number 2 and step number 1, I get negation P by means of modus ponens. And then next, negation P to R is true, that is a given premise, then R is this, then you apply step number 3 and step number 4, I get R is true. And then R to S is true, again R is true, R to S is true. By step number 5 and 6, I get an answer as S is true.